Alright, so welcome back again. So in the previous tutorial, we saw how to do social network analysis of the Bible. So in this session, we're trying to see how to do the same with the Quran, right? So let's see the packages we're using. So I'm going to import pandas, numpy, matplotlib, Wordcloud, and then Spacey to do our entity extraction. And then let's work with our data set. So let's load the data that we're working with. So pd.df pd.read underscore csv. Then I'm going to pass in my Quran test, right? So I'm loading our packages first, and then I'll load my Bible, right? Which is in this case Quran. So let's check what this data has to show us. And then this is our data, right? So this I picked from the internet, and this is what to be analyzing. So we have the original Arabic test, and then a common name, and then we have the test here, right? So we want to extract this test and find the entities within them. So that is what we're doing. So let's see how to extract all the entities in the passage, right? In this passage, or they call it surah, right? Okay, so let's see how to do that. So it's going to be my function. So let's go to def get, and then we are using Spacey to help us with that. So let's first of all, I've imported Spacey. So I'm going to create my Spacey NLP model. So NLP is going to be my Spacey load. Then I'll pass in the particular model I'm using. So ncore. There is one for Arabic which we can also use, but I want to use the English test, right? Because most of us speak English. Then let's call it as extract entities like we did earlier on. I'll pass in my test, which is a string, and then I'll pass in the entity type, which is in our case is also a string, but we are picking a person for now, right? So that is our entity type, right? Perfect. And then let's do the same thing we did. So I'll create my NLP object. So doc, going to be my NLP, and then I'll pass in my test. Then from there, I can now use entities. So we are going to loop through the entire stuff. So you can say, okay, for entity inside my doc.ents from Spacey, right? If the entity.label underscore is equal to my entity type, then I want you to return that particular test. So ent.test, right? So that is a simple function, and then we will return the entities, right? It's a simple function we are creating to help us with that. So in case I have a test and I want to extract entity from it, so entities, so we can just give a simple name. So Ibrahim was a son of Terah, right? And then it could not extract the entity because we spelled this one wrong. It's supposed to be this option here, capital, and then if I run it, I have to make sure that I'm writing the right version. So it's person. So for entity in docs, that entity, if entity underscore label is equal to entity type, then we want to return that particular entity. That is it. So this is, hopefully everything is as expected. So I think it's not finding it, but let's make it Abraham. Let's see. So it's able to find. So the reason it may not be able to find it is that the model has been trained on mostly English tests. So we may need to find, let's say, French or Arabic test to enable us to fetch it. But let's try it with the English, and hopefully we're able to find some insight into that, right? So let's apply this particular function on our entire test. We want to apply it, and let's call it as the same, so person, and this is going to be the test we want to apply it on, our test, and I'll just go with my .apply, and this will take some time, so apologies. So extract entities, right? So this is going to extract all the entities from this and place it inside this variable called person, and then we can now move on. So whilst he's doing that, we can just do our plot. We want to do a word cloud plot, and this is going to help us to know the most commonest or frequent names, right? So how do we do that? So we're just going to go with our simple function that we did the time ago. So plot word cloud, and then this is going to take in my test, or we can call it as docs, right? And then this will go with my word cloud. So my word cloud, as we did earlier on, and I'm going to pass in the word cloud instance. So word cloud coming from the one we imported above. So we already imported word cloud, in case you're wondering. Yeah, we imported from here, and that's what you're using. We also have plotly there, matplotlib, and then I'll pass in dot generate the docs, right? And then I can just go with my plt dot imshow. We can also specify that we want to plot some stuff. So image show, and then we will specify that we want image show. We want to specify that we want to turn off the others. So plt dot show or access, let's turn off the access, and then plt dot show to show our plot, right? So that is a simple function I've created, and now our data is ready. So let's check the data that we had. So it's going to be my df. If I check it out, we have our, let's go with my test, and then my person column, and then we have it here. So some of them were able to find, others is not able to find. I think that because the reason it may not be able to find is because of the model. So let's see if Spacey has a model for Arabic. Yeah, there is an Arabic model, but the issue is that if I'm going to be using Arabic, I wonder how you're going to extract them, because I don't speak Arabic. Okay, so there is one for Arabic, which is here. Oh, there is none yet. Oh, okay, there is not one yet. Arabic is not yet. Oh, okay. Yeah, we can still go on with that. At least we will find some stuff there. So Allah is supposed to be part of the entities, but because it was mostly trained on English test, we cannot find it. So that is something that we have to find a way around it. Okay, so let's also write another function. You can write another function to find the word Allah, right? And then put it there. So we already know, right? So let's run our function again. So we have finished it, but before we plot, we have to make sure that we get everything as a list. So let's go as person list, as we did earlier on. We will move through the entire data set like we did. So for item in my df person, right? I think the name we gave was person, right? We gave the name person. Yeah, so that is it. It's supposed to be called any person, but person dot to list. Want to get all of them, and then you want to say, okay, I. So for I in item, right? So the reason we are doing this is that if I go back to the test we have, which was my df person to list, it's going to be a list, right? So list of list. So we cannot use this, right? A list of lists we cannot use. So we want to fetch them out, so that if I come back and I do person list, as we said earlier, we have it in a nicer format, right? It's having some words which are not names, but it's commonly occurring, and then from there I can now plot it. So to plot it, I can simply do my plot word cloud, then I will have to pass in as my person list. It requires token, and now let's plot it and see. So the reason it's going to fail, the reason this plot will fail is because of the words, right? We need a token, not a list, right? So I have to go back and do this dot join, right? I have to do this option here because that is the only way it will pass, because this one is a list, but we need it in a way that we can get it well, right? So if I pass it here, so now it's working, right? So we need it in this way, like this option, so that it can tokenize it behind the scene and generate the word. I'm surprised that the first one they could not find Allah, but now it's finding Allah. Oh, that's interesting. And you could see that the central name, the most commonest name, is messenger. In the Bible we had David and Jesus, and then behold but here we have messenger, Allah, thou, Pharaoh, Joseph, Noah, merciful, right? And Jesus is even here. Oh, that's interesting. Cool. So that is how to do a simple word cloud. We can find the most commonest names there. So find names or characters. So this one gives us an idea. We can also do the same thing as we did. So from collections, import counter, and then from counter we will use, so let's go as a common name, names, right, which is going to be the same thing. So counter, then I'll pass in my person list, right? So I need to pass in a token and then a list of tokens, and then from there we can just get the commonest names. And you see that it's failing. So why is it failing? So the reason it's failing is that I spelled it wrong. It's supposed to be commonest name. And now we have it here, right? We can get the most commonest, so most common. Let's get the first 30, most commonest name, and then thou, Pharaoh, wow, most merciful, his messenger. That's quite interesting. Abraham, messenger, Noah, Joseph, Mary, was Jesus. This is interesting, right? And then there's Allah. Wow, that's interesting. That's something that I'm surprised about. I know something that I'm surprised about. Okay, so this is just a research, right? Okay, now so we can actually plot this. So in case I want to plot this entire stuff that we did, we can also do the same thing. So we can call it as a common Quran names TF, and then we will just pass it a pd.dataframe. Then I'll pass it here, and then we can specify the columns as we have the count. No, we have the names, and then we have the count, right? So the names refers to the character, and then we can just go back with my common Quran names, right? So perfect. So thou is the highest, although thou is not a name. Pharaoh 80, most merciful, interesting. His messenger, Abraham, messenger, Noah, very interesting, right? Research. Okay, so that's interesting. Some of them is interesting. I don't know, maybe the model is not that, but yeah, it's interesting. Now we can plot this. So we can use plotly to plot this one. So let's do plotly. So import plotly.express as ps, and then we can do ps.bar. I'll pass in my common names, then I'll pass in the x is going to be the names, and then the y is going to be the count, right? And then we can just plot it. Perfect. So we have a very nice plot of all the names, all the characters in the Quran based on these findings. So we have Pharaoh, most merciful, his messenger, Abraham, messenger, Noah, Joseph, Mary, words, Jesus, Aaron, Allah, unbelievers, gardens, Jacob. Very interesting. So this is Ishmael is also there. That's cool. That's good. So we have seen some interesting stuff within the Quran based on these two charts. Let's move on from here and do some network analysis on this, right? So as we saw earlier on, from what we did earlier on, that if you pick a particular book of the Bible or Quran, so Quran online, I don't know Arabic, but if you pick any, I hope, yeah, let's go with Fatima. If you pick any passage, right? If you pick any passage of the scripture, whether the Bible or any other book, most of the time the people within the same passage or within the same chapter, you can find relationship between them, right? That is how we be building our relationship tree, right, between them. Okay, so that is what we're doing. So based on that, because like if you pick, for example, like if you pick the Bible, you have the names like Lord Abraham, we have Sarah. So all of these things are connected. These people, these characters are connected to one another. That's why they are within the same passage, right? So that is how we are trying to build our relationship. So the same way, we'll come back again and then we will work on that from there. So this is going to be quite fast because in the previous tutorial when we worked on the Bible, we did something similar. So we use the same ideas to help us with our work, right? So we'll not be spending a lot of time with it, right? So what we want to do is that we want to, if we take our data set, right, some of our data set was, I want to say it in a better way. Let's go with this, yeah. Some of our data set, if I go back to the data set here, and then we go with my person, you could notice that here we had some names there, but sometimes they can be 2 or 3 or 4, right? So we want to be able to pick those ones out and have only those ones that are not 2 or 3. We want to avoid duplication and the rest. So let me save this data. So let's save the data for future use. So df.to csv, I'll call it as a Quran characters .csv, and then we will build our relationship, right? So before we do that, let's first of all run our function, and then we will do first of all do the cleaning first, and then we run the functions, right? That's the basic understanding. So what we want to do is that we want to create a clean data set for it. So let's do that here, which is going to be this one, and then we want to pick the person, and then the data set, we want to just find one of them, not all of them. Then we have it clean. Perfect, right? So that is better than the previous one. Okay, and then from there we will apply another function to it, right? So what you're trying to do is that we want to split, as I mentioned, that if I go back to here, it's a lot, it's this, I want to only pick these ones, right? So because I want to only pick those ones, that's why I want to just loop through the entire data set. I want to loop through it, right? I want to loop through it and then get only those ones, right? So let me call this one as person. I'm just going to override it, and now we can now build a relationship with that, right? So if I go with my clean df.shape, we have it. Well, we can now create a relationship. So what this function is doing is what I explained. So you're just going through the particular test, looping through them and finding the characters or the entities that are the same within a particular passage, right? And that is the window size we are specifying. And you're going to build a relationship here, and then you're going to find the source and the target, which is useful for building our relationship. So the source and the target is that if you go back and you find the same name, so this is going to be source target, and then the next one is going to be, say, source target, like that. So that's what you're trying to build. Let's run this function, and then let's move on to get our relationship. So I'll call it as my relationship df, and then this will be the function. So get relationship. I'll pass in my data frame. So the data frame we are passing is the clean data, and I also want to pass in the particular column. The column is also the same. We already had the entity column as person, so we will just keep everything like that. So it has finished, and if I check this, it's not a data frame yet, but if I check it, it's a dictionary of source target, right? So sustainer DAO target, DAO target, right? So that's exactly what we want to do. We need to convert this into a data frame, so we can do that with then pd.data frame. Then I'll pass in the relationship, right? So this is one of the ways we can create a data frame. So use this option here, and then this is going to be in a better form so that you can see it all, right? Source target, but there are a lot of duplicates, so we have to also remove these duplicates from it. And how do we do that? We can now, since we already have it, we can just use a numpy function to sort it out, which I'll copy and paste to save us time so that we don't spend a lot of time. So what it's doing is that we are going to sort them out, right? Sort the data based on the columns using numpy so that we have it sorted out well. And then we also want to do some count to get the weight. And that is useful so that we can know, it is useful so that we can know and we can plot it all, because some names, as you could see from here, some names are repeated more than others. So, and some of them are just duplicate. So we want to do a count to get them out. It's supposed to be this. And then we can now check it out here. So perfect. So it's working perfectly well, as you can see. And now we can do our plot. So we have gotten our relationship. We need to create our network graph. So let's create the network graph. So how do we do that? We are using NetworkX to help us with that. So let's import NetworkX as ns, and then we can now call it as Quran graph, which in our case is going to go with my NetworkX. There is the option of reading from pandas. So pandas, there's an option of reading from pandas, which is going to be from pandas edge list, right? So there are a lot. What we need is pandas edge list. Then I'll pass in the same relationship that we had like before. I'll pass in the source, which is going to be the source above, then the target, which is going to be the target, and then I can also pass in the edge attribute, which is going to be the value, that is the weight. And then I can also specify that create using my NetworkX. So there are several graphs. There's digraph, there is different forms of graph, but we want to use the general graph. This is going to create our network graph. So this is what we'll be using to do our plot, right? So I can check for the general connections between them. And how do I do that? I can simply do my, let's call this node degree, which is going to be a dictionary of the graph, Quran graph dot degree. It's this way. And then if I check this one, this is useful for us to see the size. Now you see we have it here, which is quite useful. And then let's plot it. So we have a simple function from the previous tutorial. So in case you have not watched it, you can check it out. And then that is the plot we'll be using, right? So you're using it. So plot network These are the default. We have the size, the node color, and then we have this function to help update our quirks in case we want to update it, in case somebody supplies something here. And then we are creating our plots. So this plot is coming from visualizer. So someone asked me, where is visualizer coming from? So visualizer is coming from here. I pick it from this link. So let me put the link in the code so that I can see it. So this, the source of this is from here, right? So this is where I'm picking it from, and I modified it to create a nice function. And this is the function that we have, right? So now in case I want to plot, I can now pass in my simple plot. So plot network, then I'll pass in my Quran graph. That is all. So if I go with this option here, we have our Quran graph plotted, and this is our plot, right? So this is the entire Quran. You can see grace, Mahajis, I have no idea, prophet, fear, Sabbath, wolf. That's interesting. There are some names that I have no idea. There is Moses. Wow. There's Rahman. There is, some of them are not. There's Adam. Some of them are accurate because the model is mostly English, and then it may not know some of the Arabic names. So that may be one of the reasons. But this is our plot. We can also specify the communities. So this is a simple function I created to get the communities, right? So this is a simple function to get all the communities from it based on the color, and you are mapping them. And then we need to also get the communities. So let's get the communities within our graph. So how do we do that? So we can just go to communities. There is a package that comes from NetworkX. So NetworkX community. There is NetworkX. Yeah, there is communities, as you could see here. That comes with Louvain package. So there is Louvain, and then we can use this same idea to help us with the communities, right? So just communities. I don't know why it's not picking, but yeah, it's still supposed to be communities. It's supposed to be community. Yeah, community model. And then we use this one too. And then we pass in our Quran graph. Perfect. So to get our communities, and then we can just use the same thing to plot. So let's see the number of communities within our data set. How do we do that? We just go with the length of the communities. Just 10, right? So the Quran is not as big as the other books, but this is the number of communities there. And then we can set the communities. We want to set the node size, and then we want to also set the colors, right? So first of all, let's plot the colors. In case I want to plot the colors, I have to first of all set the node colors, or let's say I want to add the communities as an attribute, right? So how do we do that? Just go with ns, then set node, then I'll pass in the graph, then I'll also pass in the communities, then I'll pass in a name I want to give to it. So let's go to as a group like we did before. Then we can now plot it, right? So in case I want to plot the entire stuff, I can also do that here, right? So how will I do that? Let's go with my plot. So let's set it first. Then to plot, I just use the same thing we did. So plot network, then I'll pass in the, by doing this, it is added to the plot, right? And I can just use my Quran graph, then I'll pass in the node color, right? It's going to be my node color. So node colors, right? But where is this node colors coming from? We have to call our function, this particular function, to create our color from the communities that we created here. So we can just do it here. then this is going to pick the graph and then the communities we defined, and we can now pass it here. You can see that now it has given us a very nice plot which based on the community. So that's quite interesting. So all the blacks belong to the same community, all the yellow or green belongs to the same, or the yellowish, orangish, whatever color it is belongs to the same, pale, the gray belongs to the same community, right? Which is very interesting. We can also plot the degree of the size, right? The entire size based on the size, based on the let's say the degree size. So we remember we had something like this. So node degree, we had this, right? We can use this one to plot as the size. So how would we do that? So just as we did above for the communities, we can use this to also plot, right? So but first we have to set it. So we can do the same thing. So let's add the degree as size for attribute, right? We want to do the same thing. So how do we do that? We can just go with my ns.set node attribute, then I'll pass in the same thing we did. I'll pass in the graph, then I'll pass in the node degree, then I'll give it size. Perfect. And now we can plot again. So I can just go back again and plot like we did. And I'll pass in the graph, then I'll also pass in the node color, right? So the node color is what I want to pass in, which is going to be my node colors. Then I can pass in the node size. So the node size is going to be the node degree. Right. So where is this node size coming from? The node size is coming from here. So you see that we have our default quacks. So if it is there, we want to update it, right? So that's what we are using here. So now it's going to override and then update. And then if I plot it, we have a nice plot again. So you can see the most Abraham. Wow, that is quite interesting. There is Abraham, there is Evil, wow, there is Allah, that's wonderful. There is Messenger, there is Pharaoh, there is Moses, that's interesting. There is Grace, there is Fear, there is Muhajish, there is Solomon, there is Muhammad, that's interesting. Wow, that's cool. So like you have seen, there is the word, there is Zachariah, and there are some people that are fathers like Hajj, and these are not that important, but the bigger ones are the ones that are having a lot of connections, right? So that's something very simple that we have done in this wonderful and exciting tutorial. I hope you have learned something. Of course, there are a lot of things you can do, right? But it's just an overview of how to do social network analysis using religious tests. You have seen it with the Bible, you have seen it with the Quran. So maybe another time you pick another book. So let me know which book you want us to do analysis on, and let me know some other things you can also do with these plots that we have, right? So thank you for watching this tutorial. In case you have a question or contribution, you can put it in the comments below. And then one more thing we can also do is that we can actually save all of this. So in case I want to save this plot, yes, I want to save this wonderful plot that I did, right? How do I do that? I'll copy this one, and then let me show you how to save it. So it's better to save. So save the diagram. How do you save it? You just go with this option here, and then let's put inside the figure because it is still plotly. Then I can now go with my figure dot write HTML. So write HTML, then I'll pass in so Quran characters, right? Node size .cs.html. Now we have it. So now if I go back to my location, we have Quran characters, node size. I can open it with Chrome, and then we have our plot here, right? So you can actually zoom in, zoom out, and see all of them, right? Perfect. That's how to save it so that you can use it for future use. So thank you for watching. And then one more, we can also check some other stuff. Like I want to know the most the shortest path between two characters in the Quran. How do I do that? I can just go to NetworkX, shortest path, and I'll pass in my graph, and I'll pass in the name. So I want to find the shortest path between, let's say, Muhammad or Muhammad, and then let's say Abraham. If there is, it could not find. Oh, that's interesting. I think the reason it could not find was that both names are not there. Let's see the name for Muhammad. I think there was Muhammad somewhere. Maybe the spelling. Maybe I spelled it wrong. But you can get the point I'm doing. Messenger. I'm trying to find the name, the spelling. Maybe I spelled it wrong. There was. Okay, it's double M. So I spelled it wrong. Wait, I think I spelled Muhammad wrong, right? Apologies. It's M-U. So Moham. I don't know how we have been pronouncing it all along like this. Yeah, okay, Muhammad Dao Abraham. So you could see that there's just a short connection. Let's try it with somebody different. So let's go with Moses. Muhammad no believers Moses. That's interesting. So let's try say, who can we try with? Moses. And then you can try with something. I don't know most of the names of the people in the Quran, so my apologies. So Moses, Pharaoh, Mary. That's interesting. So you have seen how to show the shortest path in both of these passages. So thank you for watching the tutorial. See you another time. Stay blessed.